Well, this is my EEC 10 final project, and this is a sound localization system. So first I'll walk you through my front panel. So this is the front panel. So here is a waveform charts of the right and left speakers, and here's like the instantaneous waveform charts, waveform graphs of the right and left speaker, and here's the stop button. Now let's move on to the actual code. So first, here's the one of the features. It allows me to save the sound recording. So here I can name it and then describe what kind of file and save in a directory. Then it goes to the main loop. Inside the main loop, here's the input from the MIDAC. That goes into a bandpass filter, which filters out from 500 to 10k hertz. And that's another one of the features. Then that signal is split into the right and left, which is graphed on the waveforms here and here. And then here we take the left waveform and multiply it by a scalar to calibrate the two, so that way they're at the same level. Then that's converted into an RMS value right here and here, and those two are subtracted together, and then if they're greater than some threshold, then there's a certain case. So if they're greater than 0.5, then we say that's true. Then this will write 1 to the COM3, and this is the property node to tell it it's finished writing. If it's false, then it checks if it's less than 0.5, and then if that's true, then it writes 2 to COM3, and if it's not, it just closes the serial port. And here is if you click the off button, it'll close the sound file and close the serial port. Okay, now let's move to Energia code. Here's my Energia code, and this controls the servo. So here you define the servo pin, define the servo headers and the object, and then we just set the initial position 90. And then we start the serial communication and then have it move to 0 to 180 and back to 90 as like a setup, start up, calibration type thing. So here's the two methods that I wrote, clockwise and counterclockwise. Clockwise moves it by 10 degrees and counterclockwise moves it the other way by 10 degrees. So it'll keep moving, and there's a delay of 0.1 seconds. And then in the main loop, it just checks it keeps checking if there's anything available and turns whatever it receives into an integer, and if that input's a 1, then it turns clockwise, and if it's 2, it turns counterclockwise until it stabilizes itself. So that way the sound is in the center. Okay, so here's my setup. Here's the servo. Here's your MOSFET driver. Here's the TI launchpad, MIDAC. Here's VCC, and here's ground, and here's the rest of the speaker, and these are the two speakers. So the idea is if I go like this, I'll start off by hitting reset. Or first, so first I'll hit reset. Okay, and now if I go, let me save this, a final project. Okay, and now should run. Okay, see? And then here's my lab view VI, so you can clearly see if I snap on the right, and if I snap on the left. That's my final project. Thanks for watching.